Astronomers are shocked by the imminent disappearance of the North Star, Polaris. This event is expected to be the next big thing in the world of astrophysics. Yes, you heard that right. Polaris is about to dislodge our little star once and for all. This impending celestial cataclysm will have profound effects on our telescopes on Earth, which use it as a benchmark for calibration and accuracy. Brian Cox warns that a Polaris explosion is imminent and will change the night sky forever. Let's delve into the history of the North Star and why its end is so important. For millennia, Polaris has been a celestial guide for astronomers and navigators alike. But all that could change in a few decades, if not a year. Recent research, presented at the prestigious Royal Astronomical Society in September 2023, all but sealed the fate of this unguided fire. Polaris is on the brink of disaster, an explosion that could see it disappear from the night sky forever, changing our cosmic compass. But before we delve into the possible implications of this revelation, let's examine the star in question. Also known as the North or Pole Star, Polaris holds a special position in our night sky due to its proximity to the celestial North Pole. It lies almost directly above the Earth's North Pole, giving the illusion that the northern sky is almost motionless. Polaris shines as a moderately bright yellowish-white supergiant in a constellation also known as Ursa Minor or Ursa Minor. It shines brighter than the sun and radiates significantly brighter through the cosmic fabric. Furthermore, it is dwarfed by our sun, estimated at about 40 times the radius. Despite its apparent singularity, Polaris is part of a complex triple star system. Two of them, Polaris AA and Polaris AB, stand out as one star. A third companion, Polaris B, orbits this binary pair. The complex gravitational interactions between these stars affect their orbits and brightness. This dynamic can cause irregular fluctuations in the brightness and pulsation patterns of the star, but the exact mechanisms underlying these interactions remain a cosmic mystery. In addition to all this, the frightening distance of our planet Polaris brings a fascinating twist to our understanding of time. Located 323 light-years away, the light seen today from Polaris began its interstellar journey more than 3 centuries ago. If we could see Polaris explode now, it would have actually done so all those years ago. The Earth was very different 323 years ago. At the beginning of the 18th century, humanity moved through a period marked by significant historical events and cultural changes. It was an era that marked the end of the Renaissance, the beginning of the Enlightenment, and the dawn of the Industrial Revolution in some parts of the world. Advances in science took off and figures like Isaac Newton changed the scientific landscape forever. In terms of daily life, society was still largely agricultural, with farming as the main occupation for most people. Urbanization gradually accelerated, leading to the growth of cities and the expansion of trade and commerce. Culturally, Baroque music and art emerged. So if Polaris were to explode tomorrow, it would actually do so while Earth was in the midst of a period of transition, exploration, and change, setting the stage for developments that will shape the coming centuries. Unlike the way this is, events shape things and would change for the future. For centuries, the North Star has woven its meaning into the tapestries of civilizations throughout the ages. This starlight was a guiding light for ancient sailors and travelers, lighting their way across vast oceans and unknown landscapes. Polaris is a reliable reference point that guides Northern Hemisphere explorers and allows them to chart courses with confidence. Polaris has formed a cultural and navigational cornerstone throughout the ages, shaping the story of ancient explorers, storytellers, and scientists. So how do we know a star is nearing its end? Classified as a variable Cepheid star, Polaris has very specific characteristics and cosmic size. Its predictable brightness variations helped solve the mysteries of variable stars and calibrate astronomical instruments. These rhythmic pulsations have traditionally followed a reliable pattern that has helped astronomers easily predict its behavior. But in recent research, scientists have shown a deviation from this expected pulsation cycle that has shocked the astronomical community. Polaris adopted an irregular, unpredictable rhythm of darkening and brightening. This irregularity has been widely studied, and astronomers have difficulty understanding this celestial anomaly. This deviation from the norm has caused concern among scientists, suggesting that Polaris may indeed be approaching the twilight of its existence. The pulsation period of Polaris has recently started to lengthen. The cyclic brightness of the star was previously stable, but now astronomers have observed a gradual increase in the duration of the pulsation, increasing by 4.5 seconds per year. Although this change seems small, it has significant cosmic significance, representing a departure from established behavior. There have been several speculations about this. Some blame this change on the gravitational interaction of the Polaris star system. These interactions can change the conditions of the star's atmosphere, which directly affects its pulsation patterns, or more specifically, how we perceive them. However, disagreements in the scientific community point to a much more alarming possibility. The star is dying. Irregularities in the behavior of Polaris ushered in a new era of cosmology, either as a result of gravitational interactions or as a harbinger of an imminent stellar explosion. Either way, the truth will change everything we thought we knew about triple star systems like Polaris. Speaking of how revelations change our view of the world, in 2006 we got a close-up view of Polaris thanks to the Hubble Space Telescope. Astronomers also discovered an elusive companion star that nestles so close to Polaris that it was impossible to detect in advance. This was the first photo of our celestial neighbor to capture ultraviolet light. Today we know that the companion Polaris B orbits the nuclear binary at a distance of about 2 billion miles. Although astronomers determined its existence from analyses of light from the triple star system nearly 50 years ago, its faintness relative to Polaris prevented direct observation until the Hubble Space Telescope made it possible. It all started with the launch of the Hubble Space Telescope, HST, in 1990. Its introduction opened a window on the universe, providing unprecedented clarity and defining our understanding of astrophysics. HST captured celestial wonders that fundamentally changed our understanding of the cosmos. Among its iconic achievements is an eerie image known as the Pillars of Creation in the Eagle Nebula, which shows the vast columns of gas and dust where stars are born. Another important moment came with Hubble's revelation of the deep field, a seemingly empty space that, upon closer inspection, was filled with thousands of galaxies. This image forever expanded our understanding of the vastness and complexity of the universe. HST also investigated the atmospheres of exoplanets and revealed interesting clues about their composition. The presence of elements such as water and organic molecules on these distant worlds, suggesting the interesting potential for life outside our solar system. Building on Hubble's legacy, its successor, the James Webb Space Telescope, JWST, was launched to push the boundaries of technological innovation.
Building on the lessons learned from Hubble's efforts, JWST is poised to take us deeper into the mysteries of the universe, continuing the legacy of exploration and discovery started by its esteemed predecessor. One of JWST's hallmarks is its unparalleled ability to capture images of the sky with outstanding clarity and remove the obscure shadows that once clouded our cosmic observations. The telescope works mainly in the infrared spectrum, penetrating the veils of cosmic dust and revealing celestial treasures previously hidden from human sight. At its core is a huge 6.5-meter primary mirror made up of 18 hexagonal segments that dwarfs the Hubble mirror in size and complexity. This innovative telescope heralded a new era of astronomical research, poised not only to reveal the far reaches of space, but also to reveal the mysteries of our cosmic past. With its extraordinary capabilities and unique perspective on space, the James Webb Space Telescope is a testament to human ingenuity, revealing the mysteries hidden in celestial space. Why now we know for sure that there are fascinating similarities between Polaris and Betelgeuse. Both giants are said to be nearing their end. Orion's star Betelgeuse, visible in the constellation Orion, showed puzzling irregularities in its brightness, similar to what we see in Polaris. This similarity caused the astronomical community to closely observe both stars in an attempt to unravel the celestial mystery that binds them together. Now, as we embark on this monumental journey into the cosmic unknown, the conclusions drawn from Polaris have special meaning. It is a testimony to the ever-changing nature of our universe, where cosmic phenomena transcend the boundaries of time and space. About 1.5 million kilometers from Earth to the second Lagrange point, or L2, JWST closely follows Earth's orbit around the Sun. From there, it gives us an unobstructed and stable view of the cosmic web. But a journey into space is not just a journey across light years. It is a journey through time itself. JWST uses state-of-the-art infrared instruments that can look back billions of years and record the ancient light emitted by celestial bodies. As the universe expands, this light undergoes a transformation known as redshift, moving from its original visible spectrum to infrared wavelengths or beyond. JWST is perfect for detecting and interpreting infrared signals from these distant celestial bodies.